Okay, we're going to learn the processor machine cycle. So for every instruction, a processor repeats a set of 4 basic operations which comprise a machine cycle. The first one is the control unit fetches the math problems instruction and data from memory. So for example, a student enters a math problem into the memory of a computer. So that is the first step. Okay. Then the second step, the control unit decodes the math problems instruction and sends the instruction and data to the arithmetic logic unit. Okay, so the information, the data is being fetched and then it is being decoded in the control unit. Then step 3, the arithmetic logic unit will perform the calculation of the data. So 100 times 48, it will send that, control unit will fetch the information and send it to the arithmetic logic unit to get the answer. Okay, and then the results of the math problems are stored in memory. Okay, so the answer 4800 is being stored in memory of a computer and the user can see it on the screen of the computer. Okay, so in the memory, meaning that the information is not permanently stored. It can be lost due to power off. Okay, so a memory is a temporary space where information are being held. Okay, we will learn that later. Okay, about memory and storage. Okay, so this is the processor machine cycle. So it will do the fetching, it will decode the data, and that will execute, and then it will store in memory temporarily until the user store that information in or transfer the information into secondary storage such as hard disk, your pen drive, okay, or even to transfer that on cloud computing. Okay, the microprocessor chips. So the chip capacities are expressed in word size. Okay, so the word is a number of bits. Okay, that can be processed at one time. It could be 16, 32 bit, or 64 bit. Okay, that's why when you buy your PCs, okay, you buy your handphones, okay, you will want to know what is the capacity of the microprocessor. Is it 16, 32, or 64? Okay. So the processing speed is typically represented by its clock speed. Okay, so processing speed or the number of times the CPU fetches and processes data or instruction in a second. So the higher the processing speed, meaning that the good microprocessor, okay, the faster the microprocessor. So the higher processing speed, meaning that it takes lesser time, okay, to process information or to process data. Okay, and of course the price, the price are more expensive. Okay, the multi-core chips. Okay, multi-core processors is 2 or more separate and independent CPUs within a system unit. Okay, for example, quad core supports 4 core processors. Okay, so and then we have also parallel processing. So in parallel processing, computers has the ability to divide tasks into parts that can be distributed across each core. For example, Windows 8 and Macintosh OS X support parallel processing, and these are the name of the manufacturer for different processor. Okay, for example, for i7, the manufacturer is Intel, and also Edison, the manufacturer is Intel. Okay, and if you have heard AMD, okay, the processor is called A series. So for multi-core processors, it has to have 2 or more separate processors that are independent on CPU. Okay, and it can perform parallel processing. So parallel means serentak. Okay, meaning that the computer can divide the task into different processors so that they can be distributed across each other. That's why they are faster. Okay, they can process faster, okay, than a single processor. So parallel processing works faster, okay, because it has multi-core processor. It has two or more separate processor within a CPU. And then there are also specialty processors. Okay, so example, we call it a coprocessor. Okay, so it is designed to improve specific computing operations, and the most widely used is graphic processing unit. Okay, or graphic core processor. So this is designed to handle a variety of specialized tasks. For example, 3D images, to encrypt data, and also to have standard features in gaming computers. That's why if you want to buy gaming computers, the price is more expensive because it comes with core processor. Okay, because the graphic must be more powerful than normal computer. Okay, and then also if we want to produce multimedia, or we want to process images, we want to if you want to edit videos, okay, so they have to buy more powerful computer with this special core processor. Okay, so for example, in the cars, okay, they have more than 70 separate specialty core processor to control nearly everything from fuel efficiency to satellite entertainment and tracking system. So that's why, okay, modern car now are all on digital. Okay, so if they have problem, okay, so it's very hard to fix, and the price, the labor cost is also expensive. Okay, next we go to memory. Okay, this one that I have mentioned before. Okay, so memory is the holding area, okay, for data, instruction, and information. Okay, so memory is contained on chips that are connected to the system board or motherboard. Okay, so there are three well-known types of memory chip. The first one is RAM. Okay, RAM stands for random access memory. And then we have ROM. ROM is read-only memory. And then we also have flash memory. Okay, so RAM, ROM, and flash memory, they are not permanent. Not permanent. Okay, not permanent. They can be lost. Okay, so RAM is used to store programs and data. ROM is used to fix startup instruction, meaning that every time you boot your computer, okay, the ROM memory will fetch all the information about the computer. So ROM holds all those startup instruction, okay, inside a computer. Okay, and then a flash memory is for flexible startup instruction. Okay, okay, the not permanent means, okay, it's only referring to RAM, okay, because RAM, it holds programs and data, but ROM, it has that information being stored and it will be there forever, and same goes to flash memory. But RAM is not permanent, it will be lost. Okay, like for example, if there is power cut, then information will be lost. Okay, let's go to the next slide. Okay, memory. So memory, we can divide into two types. Okay, volatile and non-volatile. Volatiles mean disappear. Okay. Okay, if you have power off, it will lost. Okay, so this one is permanent. Okay, so it can lose its contents when the power is turned off. This includes RAM, cache memory, and also virtual memory. But for non-volatile memory, it doesn't lose the content when the power is removed, okay, or when the power is off. Okay, let's say you have blackout, so it will remain in the computer. So example include ROM, because ROM holds all the startup instruction. Okay, so it has to be permanent, because next time when we boot the computer knows, okay, information about that computer. Okay, and also flash memory. So these are non-volatile. But for volatile, it will lose when the power is off, and the example is RAM. So make sure you don't get confused between RAM and ROM. RAM can disappear, it's a volatile, it's only temporary. Okay, but ROM is permanent. Okay, and also flash memory. Random access memory chips hold programs and data that the CPU is presently processing. So it is volatile and it's also temporary. Okay. So the contents can be lost when the power is off. Okay. And then cache memory is also temporary high speed holding area between the memory and CPU. So we can have additional RAM to be added using an expansion module called DIMM. Okay, dual inline memory module, so we can expand, okay, our RAM. Okay, so this RAM is volatile. Okay, means the memory can be lost when the power is off. And then we have virtual memory. So virtual memory, okay, it's not real, so it's virtual. Okay, so it is virtually dividing a program between a memory and storage that enables the system to run very large program. Okay, so how does it what is the function of virtual memory? So it actually dividing a program between memory and storage that enables the system to run very large program. Okay, so just remember that's the definition for virtual memory. And memory is expressed in bytes. Okay, so 1 terabyte is larger. Yeah, it's very large. Okay, as compared to 1 megabyte. Okay, so these are the unit that always used in the memory. Okay, megabyte, gigabyte, and terabyte. Okay, so for virtual memory, so it is known as a memory management capability that uses hardware and software to allow a computer to compensate for physical memory shortages by temporarily transferring data from RAM to disk storage. Okay, this is RAM. Okay, and then this is hard disk. So within hard disk, we have virtual memory. So it will, for example, temporarily transfer the data from RAM to disk storage. Okay, to disk storage. Okay, hard disk, and then it can be needed by the CPU. Okay, so that is virtual. So it's not really really exists, but it's one capability, okay, of a memory system, okay, of a memory management system. Okay, so that it can allow computer to compensate, for example, to reserve or to save file. For example, you are doing your Microsoft Word and suddenly there is power off, and then you haven't even saved that information. Then when you turn back the laptop or computer, then they actually have make a backup for you. Okay, so that file or information are being stored in the virtual memory. Okay, so temporarily it transferred into this storage, and if you don't want it, it will be removed. You said you want to copy that, you want to save it, you save it immediately. If not, later on it assume that you don't want it and it will disappear. Okay, so that is virtual memory. Each location in memory has address. So memory is expressed in bytes, okay, as we have seen in the previous page, and then it is measured in kilobytes as well, KB, megabytes, gigabytes, and terabytes. Okay, so for example, okay, kilobyte, okay, it means 1000. So megabyte 1 million, giga 1 billion, and tera is 1 trillion. Okay, this is the approximate number of pages of a text. So if it's 1 kilobyte, it's about half page of text. Okay, and then can you imagine about 1 terabyte is about 5 trillion. No, is it 1 trillion types of bytes? So this is about 500 million, okay, of pages of text. Okay, so this is the exact number of bytes. And then ROM. What is ROM? Okay, ROM is read-only memory. So the information is stored by the manufacturer. So meaning that when we bought a computer, so the information is being ready. Yeah, same like you buy a mobile device, okay, a handphone. If you want to reset, you will reset the manufacturing or the factory setting. So the information are stored by the manufacturer. It is non-volatile and cannot be changed. Okay, it is permanent but cannot be changed. CPU can read or retrieve data and program in ROM, but the computer cannot change the ROM. That's why we always have that the original setting of a computer or a mobile device. So if anything happen, we can set it back to the original. Okay, and then it also contains special instruction. Okay, to start the computer, to access memory, and to handle keyboard input. Okay, so this is the instruction for a ROM, because computer doesn't know how to work. ROM will help the computer how to function. Okay, by telling the computer, okay, how to handle keyboard input, how to access memory, and how to start itself. Okay, and then flash memory combines the features of RAM. Okay, but it can be updated because that is flash memory. It also contain because that RAM can be updated, yeah, but ROM cannot be updated. Okay, but it is non-volatile. It doesn't lose the information when the power is off. So, and also flash memory contains startup information of basic input output system, or called BIOS, and it also contain certain amount of RAM capacity, and contain also information about type of input output devices connected with the computer. Okay, and also many ROM chips are also being replaced by flash memory. Okay, so in the new, recent computer generation, okay, many ROM chips are being replaced by flash memory because it is more the features is more better than ROM chips.